describing a graph, right? So you could actually physically, if you wanted to take the time, you could actually physically draw a graph of these functions. So you could draw a graph of f of x being positive in this interval and positive in this interval and so on and so forth. Do you remember the first day we started learning about curve sketching and we drew that ginormous chart over here? Yeah. And it was like probably one of the most confusing things you guys have ever done. That's essentially what this chart is, but they're giving it to you ahead of time. So you're not necessarily creating it, they're just giving it to you ahead of time. We are going to use this chart, however, to figure out different pieces or different information about the graphs that we're being given. So do me a favor and look down here. A lot of the words in the descriptions might throw you off, but they are mostly just there to be mathematically correct and don't always necessarily have applications, I guess you could say, to the problems. So let's look at this one first. The twice differentiable functions f and g are defined for all real numbers x. What does this mean, twice differentiable? Good. It just means you can take the second derivative of them. That's all that means. Okay, they're twice differentiable. It says values of f, f prime, g, and g prime are for various values of x are given in the table above, and you guys can see that from up here. They give you different values for 1 and 3 and -1, -2. First question, find the x coordinate of each relative minimum of f on the interval from -2 to 3. Justify your answers. All right. Here's what I'm going to do. It really doesn't help you guys at all if I sit here and tell you how to do all these problems. So I think it's going to help you if you actually talk about them in your groups. I'll give you not a ton of time, because we don't have a ton of time if we're going to get through a lot of them. But I'll give you probably just a few minutes to talk about the first one, and we'll do it again for the next one and the next one. But talk about the first one and think about how you guys might go about solving to get the answer for part A. So 2 minutes on the clock, okay? Talk about it in your group. How might you go about solving to get A? So, tell me what you guys talked about in your groups. Say it a little bit more louder. So I hear that there is a minimum value, because remember we're looking for a minimum value. I hear there is a minimum value where what goes from negative to positive? Close. And I think I know exactly what you're talking about, but you're saying it wrong, so I want to make sure you're going to say it right. There's a minimum value when something goes from negative to positive. I'm sorry. You're right. Let me rewind. I'm sorry. I'm so sorry. What a horrible person of me to tell you that you're wrong when you're actually right. I heard you say something else. You are absolutely 100% correct. There is a minimum value when f prime goes from negative to positive. I thought you meant when it went from decreasing to increasing. So I'm sorry. You're right. We are looking for where f prime of x, this row right here, so this is the row we're looking at. Houston says we're looking for where f prime of x goes from negative to positive. Because if f prime is going from negative to positive, that means that the original function is going from decreasing to increasing. And that would be a minimum value. So that is absolutely correct. Where do we see, what x value do we see this changing from negative to positive? At this x value right here. So notice that this is the place where f prime changes from negative to positive, which means that this is the x value I'm looking for. Why does this equal 0? What does that mean that this equals 0? That's the y value. So notice that the first derivative equals 0, which makes sense. If the first derivative equals 0, the original function had a horizontal tangent. So the only x value where it changes from negative to positive would be x equals 1. So here's how I'm going to write my answer for A. I'm going to write x equals 1. And then to justify your answer, do you guys remember this little thing that we put up here? And I have a little poster up here on the wall. So if you haven't noticed it yet, you guys can notice it now. It says, I know that x equals 1 is a relative minimum because it is a 0 of f prime of x, and f prime of x changes sign from negative to positive at x equals 1. That would be your answer to justify. Now again, we're going to be doing these free response questions a lot, so I want you guys to write it down now as the first time. I will not make you write it down every single time because I know that it would be super, super tedious for you guys to do it every single time. However, I do want you guys to have it in your own notes as many times as possible because I do believe the more times you do something, the more ingrained it is in your memory, and hopefully you guys won't need to look at the poster anymore eventually. Hopefully eventually you guys will just know it so well in your minds that it will be second nature to write that justification. So again, I know that x equals 1 is a relative minimum because it is a 0 of f prime of x, and f prime of x changes sign from negative to positive at x equals 1. By the way, you might not be very happy about this, but this is only worth 1 point on this question. So that answer with that justification is worth 1 point. You might not be happy about it, but it makes sense because it's not a very hard thing to figure out, so obviously it shouldn't be worth a ton of points if it's not very difficult to discover.
So for a question like this one, if you didn't write the justification, is it going to be considered no?
Yeah, I think that, it depends. I don't remember, and so I need to... Part B says, explain why there must be a value C in between -1 and 1, so we're looking in between -1 and 1 here, okay? Explain why there must be a value C in between -1 and 1 such that f double prime of C equals 0. So again, talk about it in your groups, spend about 2 minutes talking about it, and then we'll discuss it as a group. Alright, let's talk about it. So my hint to you guys was Rolle's theorem. Who thinks they figured out how Rolle's theorem applies to this problem, to part B? Was that a yes?
Yeah.
Go ahead.
Because the f prime of -1 and f prime of 1 equal the same thing, the f double prime of c has to equal 0.
Beautiful. So he's looking right here. He says, notice that f prime of -1 and f prime of 1 both equal 0. If you actually graph this, if you have two zeros on a function and it's negative in between those values, at -1 and at 1, I have a 0 here and I have a 0 here, and I know it's negative in between. The only way for me to get from 0 back up to 0 again is to actually have a turning point somewhere in the middle, correct? Which means that if this is the first derivative I'm looking at, the turning point would be a 0 on the second derivative. So Rolle's theorem says it has to be continuous, it has to be differentiable. Guess what? That's what these things mean. Twice differentiable means that it's continuous and differentiable on two occasions. So twice differentiable is telling us those two things. It is continuous, it is differentiable. The third one also holds. F of A equals F of B because they both equal 0, which means that the conclusion is true. If all three of those things are true, then there must be some value C in this interval from -1 to 1 where f prime of C, so the derivative of the derivative is what?
0.
What's the derivative of the derivative? The second derivative, right? The derivative of the derivative is the second derivative. So with Rolle's theorem, f prime of C, so the derivative of this function, which is the second derivative, equals 0 at least one time. So to go back to part B one more time, it says explain why there must be a value C in this interval such that f double prime of C equals 0. You would essentially just list Rolle's theorem. I know that it's continuous and differentiable because it says that it's a twice differentiable function. I know that f of A equals f of B because f prime of -1 equals 0 and f prime of 1 equals 0. Excuse me. Which means that there must be some value in this interval from -1 to 1 where f prime of C, the derivative of this function, so f double prime, also must equal 0 at least one time in this interval. So I'll kind of write that out with you guys so you know what to write on your papers. So essentially, I know that it's continuous and differentiable on -1 to 1 because it is a twice differentiable function. I know that f prime of -1 equals f prime of 1, which equals 0. Therefore, using Rolle's theorem, f double prime of C must equal 0 at least once in the interval. And I'll write it up here because I don't have enough room. This part of the problem, by the way, this part of the problem is worth 2 points. You get 1 point for pretty much saying this, that f prime of -1 and f prime of 1 equals 0. You get 1 point for that. And you get another point for saying that the theorem actually works. On the answer key, it says to use the mean value theorem, which you could also have used. You could have used the mean value theorem to show that the slope between both of these points is 0, therefore there must have been a turning point somewhere in between. But that's okay. You can use Rolle's theorem, you can use the mean value theorem, as long as you can figure out a way to explain why what you're saying works. So this part was worth 2 points of the actual problem. Can you guys start to see now how these questions, it's not like, in order to pass, here's my philosophy. In order to pass with a 3, you have to have a really solid foundation of calculus, a really solid foundation. A lot of these questions you can get with a very solid foundation of calculus. In order to pass with a 4, you need to have a solid foundation plus a little bit of extra knowledge, okay? In order to pass with a 5, you have to know a lot about calculus. So you'll notice as we go through these free response questions, as we go through these multiple choice questions, some of them, it's like, how am I supposed to remember that? Like I heard some people saying like, oh, you have to pull in Rolle's theorem. How am I supposed to know to pull in Rolle's theorem? This is what is separating the people that are getting a 3 from a 4 from a 5, is people that get a 5 know all these theorems. You can get a 3 without knowing all of them though. Does that make sense? So you might not be able to like pull in every single thing, and you can still pass just fine, but you might not get a 5 is what I'm trying to say. A 5 is somebody who knows everything very well and is able to pull it in from every direction on every type of problem, and it's always in their minds, kind of like circling the drain, like what do I use, what do I use? And remembering everything we've learned and figuring out what they need to use. So keep that in mind, is that it's not like you're going to fail just because you don't know one thing. You might not get a 5, but you can definitely pass by having a solid foundation and not knowing every single little detail.
What's the average prime?
Of the AP Calculus test? You mean in general?
Well, like here.
It's different every year, but it was last year, it was... we're going to skip part C for right now and part D. Notice that part D is probably something that doesn't look familiar to you yet, and that's okay. We have not covered integrals yet. We'll get there second semester. Part C you could work on, but I don't want you guys to take time right now. I'd rather work on other stuff for that. So let's flip it over to... Flip it over to 2013, number 4, the next one.
Wait, on the top, quick question. What is that little sign?
What little sign?
It looks like a big L, and then it has a 3 in it, and then
Does it look like a big L or a big S? It's called an integral. That's what we're going to talk about second semester. Integrals is pretty much the entire second semester. All right. Number 4 on 2013. So write this down on your paper so that you guys know that if you want to look back on it later, you can. We can answer the first 3 questions on this. So we'll see if we can get more than this done, but at least we're going to answer these 3 questions. And then we'll continue from there later. So it says the figure above shows the graph of f prime of x. So again, we're looking at the first derivative. All right. The derivative of a twice differentiable function of f on the closed interval from 0 to 8. The graph of f prime of x has a horizontal tangent line at 1, 3, and 5. So you guys can see that it has a turning point at 1, at 3, and at 5. Those are horizontal tangents. The areas of the regions between the graph of f prime and the x-axis are labeled in the figure, and the function f is defined as all real numbers and satisfies f of 8 equals 4. This last part will have no application to you yet, not until you guys get to second semester. So please don't worry about anything about the areas. Okay, the areas will have no application to you until second semester, and that last sentence will have no application. So you probably know what it means, but you might not know what it applies to these problems. So we're not actually going to do all the problems, for the reason that you guys don't know how to do those parts yet. So, part A. Part A says find all values of x on the open interval from 0 to 8 for which the function f has a local minimum and justify your answer. So, spend 1 minute talking about this in your groups. Time's up because this is literally the exact same question as part A on the previous example.
I guess me.
It's just that now instead of being given a chart, we're given a graph. So, somebody besides this table back here, so not table 7 because this table's already answered, and somebody besides this table because they've already answered. So one of these other tables, Tell me how we know where f has a local minimum.
Wait, where it goes from negative to positive.
Good, where what goes from negative to positive? Good. We're looking for where f prime goes from negative to positive. That's where f will have a local minimum. So looking here, where do I go from negative to positive? 6. That's the minimum. So down here you should write x equals 6 as your answer for part A. Yes. Guys, for the justification, I'm not going to make you write it down because, again, it's going to get tedious and redundant, but you would literally just write that. Do you guys see where somebody was like, that sounds super redundant? And it does sound redundant. So if you want to cut it down a little bit, that's fine. But essentially, your justification needs to sound something like that. So I know that x equals 6 is a local minimum because it's a 0 of f prime of x, and f prime of x changes sign from negative to positive at x equals 6.
On that sense, like what information needs to be on the justification for sure? Like,
The only part that's really redundant is like repeating the x equals x value at the very end, like that last part, and then maybe repeating that it's f prime of x twice. But honestly, like, the clearer you are, the better. That's why I wrote it very, very clear, so that you guys can make sure you're as clear as possible as well.
and we could use that justification for all 6 true and false questions?
No, it usually only works with this one. So for the justifications for the other ones, I'll show you guys different ones later. All right. That was worth 1 point. That answer with justification, by the way, was worth 1 point. Here, do you guys want to hear the justification that they wrote? Here's the answer they wrote. X equals 6 is the only critical point at which f prime changes sign from negative to positive. Therefore, f has a local minimum at x equals 6. Pretty much the exact same thing as that, just maybe in a little bit of different words. But I say memorize it one time in one way so that you guys can use that every single time to use what you need to write. All right, so x equals 6. Perfect. That's worth 1 point. Spend about a minute or two discussing the second one. Determine the absolute minimum value of... Actually, you guys don't know how to do that one yet. Skip that one. I'll talk about absolute value, absolute minimum later. Try this one. Part C. On what open intervals contained in 0 to 8 is the graph of f both concave down and increasing? Explain your reasoning. So, part C. Spend 2 minutes trying to do part C. Let me highlight the areas we're looking at. So we are looking at decreasing and positive right here. Oops, let me highlight it in a smaller highlight. Right here and right here. Do you guys agree that both of those places are positive? Yes, they're both positive, which means that the original function is increasing in both of these places. And do we agree that both of them are decreasing? Which means the original function is concave down in both of these places. So this is concave down increasing, and this is concave down increasing. Who can tell me what this piece is right here? Concave up increasing. And what's this piece right here? This is concave down decreasing. Concave down because it's going down. It's decreasing, so it's concave down. And the original function is decreasing because this part is negative. This would be concave up decreasing, and this would be concave up increasing. All right, do you guys see how it's kind of changing as we go through? So what are these two intervals? What's this first interval? 0 to 1, and this one? 3 to 4. So my two answers are from 0 to 1 and from 3 to 4. Justification. Somebody said, I don't know how to justify this. Here's how I would write it. I know that these are the only two intervals where f is both concave down and increasing, because it's the only two intervals where f prime is both what? What is f prime for concave down? Decreasing, and what is f prime for f being increasing? And positive, because I know it's the only two intervals where f prime is decreasing and positive. And I want you guys to know one more thing. I want you guys to know that whoever's reading this is a person. It's not a computer. So here's the good thing about this. Maybe you get to the AP test and you're like blanking and you don't remember how to explain it. The person that's reading your test gets to see all of this. So if you actually went in and highlighted like that, all right, and you're like, and you did your very, very best to explain it, and you wrote like C graph above, and you actually highlighted the two areas where it was going down and whatever, the more you can do, the better. If you have time, I say, if you have time, the more you can do, the better, to help whoever's reading your free response question to actually grade it appropriately as according to what you know. Does that make sense? So the more you show them that you know, the better grade you will get, in my opinion. So if you have time, do all the extra snazzy stuff to help them understand what you mean. All right. We have about 5 minutes left, so I want to look at one more free response question before we're done. So go ahead and flip it over one more time to flip it over to 2009, number 6. 2009, number 6. It's the second to last one. All right. So look up here. This is a graph of f prime of x. And I told you guys, they love to give you this one. They love to give you the first derivative and ask you questions about the original function. It says the derivative of this function is defined by this equation right here. And it says the graph is continuous, and it has x-intercepts here and here, and it's a semicircle followed by a line. All right. Question number 1. Question number 1 says, or sorry, not a line, but you know what I'm talking about. This is an exponential function. Question number 1 says, in this interval from -4 to 4, find all values of x at which the graph of f has a point of inflection and justify your answer. Take 2 minutes. Try and talk about what the answer to that is. Yeah, leave the packets on the desks and I will come around and collect them. So here's the answer. -2 and 0 because it changes concavity from decreasing to increasing and increasing to decreasing.